Okay, so let's just start it and create some surfaces, sets, and all the stuff that we will be needing for defining our interactions, because by default I have modeled each and every part separately. I need to tie them together. I need to create some interaction between these two. I need to embed my rebar within the slabs and base pads and all these stuff. So for that you need to have some sets and surfaces already created. I would recommend, because you can also do it at that time, but it is always a good idea and time saving idea to create all these things at the start. Okay, so let's just start it. So that's all we need for surfaces and sets. Now before assembling the model, it is good idea to also create some interaction. For that definitely we need to have a step as well. Let's see. Okay, I do not have any initial, but I want to be, I want to conduct a frequency analysis. So for that you need to select here from the procedure tab as linear perturbation and then frequency. Continue. After selecting that, you can choose your non-linearity. If you want to turn it on, you can choose the eigen solver, whether it is Lancaster, subspace or EMS. By default it is Lancaster, so if it does not give you any error, it, if it give you accurate result, so you do not need to change it. So the important here is that number of eigenvalue requested. How much do you want? Do you want to have all the frequency in range, or you want them to be specific? Let's suppose I ask Abaqus to give me first 5 natural frequency of the my model, and there are another other things some that you can do. If you want to identify the minimum and maximum range of frequency, that is your interest and all these stuff basic. And if you choose some others, matrix storage, if you are choosing this thing, so other will be by default it will be symmetric only, it will deactivate others. So if you choose other two, it will be activated, so you need to choose these things very carefully. And okay, non-linearity is off, so let's just keep it off. I can in fact it cannot be turned on for frequency analysis. Alright, so now coming to the interactions. uh, First of all, let's start with the embedment of rebars, which will be embedded region constraint type. Okay, let's just define all interactions, and we'll talk about these later. So this is how I'm doing these things. It is always easy for me if I already have some surfaces, so I just only need to choose them, and whether I also need to check whether it is accurate or not. So and continue. Alright, base pair top and 4-1 bottom, and okay. So you can see that now these two surfaces are tied up together, and I will do the same for the rest of them. Actually, there is another thing that to mention here: which surface to be choose as a master and which to be chosen as a slave. uh, One thing that I've read in Abaqus documentation is that usually a strong surface should be chosen as a master surface, and in some cases where you realize that both of the surfaces are having similar behavior, or they have some similar dimensions or anything, uh, based on that you can realize that this surface is more strong and this one is less strong. So in that case it doesn't matter what surface you choose, but for those where there is a clear visible difference, that okay, this surface is strong enough, so I could choose this as my master surface. Okay, so let's continue and create other surfaces as well. I mean other constraint, obviously. You might have realized something from my names, that I'm going from top to bottom, and I'm naming my constraint in such a way that it is easy for me later to identify, okay, what was this constraint. You can see that it is slab 1 to floor 2, which means slab number 1 this attached to floor 2. So definitely I know, okay, the slab 1 mean the top of the slab, and floor 2 means the bottom of my floor 2. So because this is the only connection that we have between the slab 1 and floor 2, so in this way it is always a better idea to name your constraint manager in such a way that later for you it is easy to identify them. There is another important thing that I wish to mention here, that at some point if you realize that I should make this as a slave and this as a master, or this as a slave, or this as a master, so you can always click this icon, switch surfaces. If you switch it, so you can see now this is slave and this is master. So in this way you can easily switch surfaces between these two. Okay. Alright, so I just came to know that I have not defined the surface for my these walls, the side walls. Okay, it's not a problem. Just let me show you how you can do it from here. If you do not have already defined surfaces, so you can just create a direction and name it, and let's okay, choose the master surface. Choose surfaces because I do not have any surfaces to choose from here, so I can select region now, and let's just rename it first. This is how I do it. Now I can see I already have surfaces over here, slave surface and master surface, and I have already defined the interaction over here. So I think the only interaction that is left is to attach this slab to the surface of this thing. So this is how you can model, or you can, I would say, create interactions for your model. That's all for this video. I'll see you in the next video where we would be properly assemble our model, and also we will came back to our step module if we want to some further identification, and we also will deal with the loading protocols, and also if there is any, and also the meshing, and then we'll submit the job. Okay, see you soon.